Okay, Michael, so this is it. Why don't you help me remember what we learned in this one marathon session that was not all distributed over multiple months?
Sure, or years. Um,
Hmm.
so MDP. So we talked about Markov decision processes, and we said
Right.
what that meant,
Okay, so
uh,
that's the first thing we did is we talked about MDPs.
and that an MDP consists of states and rewards and actions, and like that, transitions, discounts.
So you said discounts, and I just want to point out that there are some people who think that that's a part of the definition of the problem, and there are some people who think that that's more of a parameter to your algorithm,
Ah, okay, all right. So there's some people who think of it the right way.
like me, and some people think of it the wrong way. So I tend to think of the discount as being something that you're allowed to fiddle with, as opposed to it being a fundamental part of the MDP.
Well, then why not fiddle with the rewards?
Sure, you actually are allowed to fiddle with rewards, but this
Oh,
is
you're
supposed
very,
to be.
very
Yes,
open-minded.
I am open-minded. I believe very much that rewards should be able to marry other rewards. In any case, the important thing here is that there's some underlying process that you care about that's supposed to represent the world. States, rewards, actions, and transitions capture that fairly well. Discount is, in some sense, an important part of the problem because it tells you how much you want to care about the future versus the past. But it's reasonable to think of that as something that you might want to change outside of the kind of underlying physics of the world.
I see. Okay, well, that's
Mm.
fair. Yeah, in some sense, the states and the actions and the transitions represent the physical world, and the
Hmm.
rewards and the discount represent the kind of task description.
Right. And of course, you say that, but if you could decide to define states differently, and doing that would impact both your actions and the transition function and so on and so forth. But the basic idea is right, which is there's some underlying process we're trying to capture. And I think it's exactly right to say states, actions, and transitions sort of capture that. And rewards and discounts capture more about the nature of the task you're trying to do in that underlying world.
Okay, and in that context, we talked about two really important concepts: policies and value functions.
Hmm. Which we sometimes call utilities.
Right.
And how do utilities differ from rewards?
The utilities factor in the long-term aspects, and the rewards are just telling you the moment-to-moment.
Right.
Utilities are like a group of rewards, like a
Yes.
gaggle
Or a murder.
of crows.
A murder of
So
rewards.
uh, that we talked about how we can assign value to an infinite sequence of rewards,
Hmm.
but it helps if we use discounting to do that, so that we don't get infinitely large sums.
And that allowed us to deal with infinite sequences, but treat them as if their value is, in fact, finite, thus solving the immortality problem.
And let's see. Then we kind of, and the stationarity was a really important part of that.
Yep. In fact, kind of drove everything.
Yeah. And all these things were tied up together in the Bellman equation itself.
Yes, which is an awesome equation and deserves capital letters. Is that it?
And then, well, then we solved the Bellman equation using value iteration and policy
Ah,
iteration. I think
yes.
that was it. All right. So are any of these polynomial time algorithms?
Well, the way we've been talking about them, no, but you can map these into linear programs and turn them into polynomial problems or polynomial time algorithms. So
Hmm.
yes, these problems can be solved that way. But actually, that reminds me of something that we haven't said and that we haven't learned today that I think is worth mentioning, which is we've been talking about, this section of the class is about, or the course is about reinforcement learning. But we actually haven't done any reinforcement learning here because we know everything. We know the states, we know the rewards, we know the actions, we know the transitions, we have some discount. We have been solving MDPs, but that's not quite the same thing as doing reinforcement learning. However, it's very important to do these things to make it easier to think about how reinforcement learning works. So in reinforcement learning, the difference is you don't necessarily know the rewards and the transitions, or even the states and the actions for that matter.
I see. So, okay. So when are we going to get into reinforcement learning then?
Next time. And when I say we next time, I mean you next time. That's your assignment.
Oh,
Learn all
okay.
about reinforcement learning and talk about it next time.
All right. I got to go and get to work then.
Okay. Well, you have a good one, Michael.
Thanks for all this. This is really cool.
It is cool. Bye.
Bye.
Bye.